Welcome to this unit in business mathematics. This time I'm going to talk about how we can calculate the duration or the required duration for a specific investment. In this regard, we can directly start with an easy example to illustrate this idea. So we have a deposit of 5,000 euros. This deposit has grown or has to grow to 12,000 euros, assuming an interest rate of 6% per year. So in this regard, the question we would pose is, how long does it take for this deposit of 5,000 to actually become 12,000 euros? Then we have a second question, how would the result change if we assume monthly payments? So let's start with the easier version. In the easier version, we take our formula for compound interests. That's the formula here, the Kn equal to K0 times 1 plus I to the power of n. And then we solve this for n. So first we divide by K0. Then we apply the logarithm on the left and the right. We can use the formula for the logarithm where any exponents can be pulled in front of the logarithm. That's what we're doing on the right side of the equation. I will just show you. So that's what we actually did here. If we apply the logarithm, we can pull this n here in front of the logarithm. And then we simply divide by ln 1 plus I, which is done here. And the upper part, this is just written in a slightly different fashion to make it easier to note down here. So that's the formula we can use for the duration. But you're still free to just insert your values here in this formula and then just solve it by hand, doing more or less the same thing as you did here. So if we just insert our values, we could, as I said, also do this step by step. In this regard, divide by K0, take the logarithm on both sides, and divide by ln 1 plus 0.06, giving us here an n of 15.02. So it takes roughly 15 point something years or periods for us to get from 5,000 euros to 12,000 euros, assuming we have an interest rate of 6%. That's already everything there is for this first part. In the second part, and I just copy the exercise text here, we're going to do the same thing, but with monthly interest payments. So we can just copy the formula for sub-period interest payments, which looks similar to the one we used in the slide before, with the difference being here the I is divided by t and the n is multiplied with t. Then we do exactly the same thing as we did before. We simply solve for n by dividing by K0, then applying the logarithm on both sides of the equation. There's only one difference here. At this point, we have nt up here. So in front of the logarithm at this point, we also have n times t, and we divide by t times ln von 1 plus I. With numbers, we can do it a similar fashion as before. We just insert our values we got from the text. Here, t, it's monthly payments, so t is 12. We proceed in a similar fashion as before, divide by 5,000, apply the logarithm on both sides, pull the 12n in front of the logarithm, and then divide by 12 times ln 1 plus 0.005. At this point it's 0.005 because we had to divide the 0.06 by 12. Well, if we do this, we get this as a formula, or as a result 14.63. So it takes less time than before to actually achieve our goal. Well, at least a little bit, less than half a year, because, well, we have more interest payments. So compounding actually takes, well, not significant, but takes off at least a certain part of the time we need to achieve our goal. So here it's only about 14.63 years we have to wait to actually achieve this goal. And well, that's then all there is to this exercise. So I hope you enjoyed it, and well, see you soon.